Hello and welcome to today's Tech Talk session. We have an exciting session planned for you in which we'll discuss Oracle's observability and management features for the Oracle Database Cloud Services. Today, we're joined by a very special guest speaker, Derek Harlow, who is a program manager from Oracle's Observability and Management team. Welcome, Derek. Why don't you take a few seconds to just tell us a quick tidbit about yourself?
Thank you. Yes, Derek Harlem in the Observability and Management group, focused mainly on database management and operations insight services. I'm excited to go over the new features that we have and some of the cloud level support we're going to be providing. I was a DBA for almost 8 years before this, so I have quite a bit of experience in the field there.
All right. We also have another supporting cast member, Sriram. If you just take one quick minute to say hello to our guest, that would be wonderful.
Hi, everyone. This is Sriram here. I am again part of the product management team for Cloud Observability and Management. We hope you enjoy the session around database manageability for cloud databases.
Thank you for that. Well, let's take a quick look at the agenda. Right. Today's discussion will provide you with exposure to many cool tools that can be used to simplify how you monitor, tune, and administer your cloud databases. We'll start the discussion by first reviewing the available Oracle Database Cloud Services, and then take a quick review of the many service types that are available in OCI. We'll then turn our attention to the main topic for our discussion, which is to discuss the available observability and management features for the Oracle Database Services. We will start by discussing the Oracle Database Management Service, which is used to enable ability to monitor, tune, and administer one or many fleets of databases from a centralized console. We'll also drill into features like the Performance Hub, which provides us a single view of database performance, and AWR Explorer, which adds data visualization for us to be able to quickly understand the AWR data. We'll also take a look at how to gain near real-time performance diagnostics by leveraging the top activity like drill down feature, and wrap things up with a peek of how the tools in the operations insight services are used to produce data-driven performance and capacity planning solutions. We'll then show you a quick set of demos so that you can walk away with a good understanding of what the things look like that we're giving you exposure to. So a packed hour of great information that I hope will bring you a lot of value. Well, the first place to start, again, is to really just talk to you about the Oracle Cloud Database Services that we offer. As you can see, the Oracle database offerings, we have our base database service, which is our database service that's based on our VMs. It provides single instance or two-node rack capabilities, and lots of OCPUs, and its ability, again, to provide you either single instance or rack. When you need a little bit more power or scale than is available in the base database service, we offer a set of database offerings that run on the Exadata platform that you are able to consume either in the public cloud or in your data center. Right? So not always can you go out to the public cloud. So we ensure that the same or Exadata platform that you have on premise, you can also take advantage of that on dedicated infrastructure in the public cloud or in your data center when you need to handle data sovereignty, data residency, so that you can use it as Exadata database service on cloud at customer. The next thing that is also makes our Oracle Cloud Database Services such a great value is that you also get a choice of how you manage. So the base database service and the Exadata database service are considered co-managed infrastructure, where Oracle manages up to the hypervisor and you manage the database and your data. But we also offer autonomous databases, so a fully managed service where Oracle will handle the whole thing for you. And again, our autonomous database services can be consumed in the public cloud or in your data center. In the public cloud, one of the really cool things is that the autonomous database shared really gives a very low cost point entry where you can do all of the really cool development on the latest technologies without any real commitment So all the way down to things as small as fractional OCPU deployments. Oracle's committed to making it easy for you to meet your business needs, right? If you have the business needs to keep data in a certain geography, right, because of data residency rules, not a problem. As you can see here, Oracle continues to deploy cloud infrastructure globally, and whether it's for government clouds, commercial clouds, and we've also been continuing to help support multi-cloud deployments. So you can see that we have a number of data centers that are already established with interconnectivity between Oracle and Azure. But these types of initiatives will only continue to grow as Oracle continues to deploy new regions across the globe. But, a question that I always get is folks will say, is the Oracle Cloud just for the Oracle database? And the answer is absolutely not. It's for all workloads. The Oracle Cloud is full of developer-rich services and platforms that enable them to do low-code development on the latest and greatest methodologies, such as DevOps, using techniques such as microservices, right? And developers love to use things like Terraform to do things to develop and deploy infrastructure as code. So the Oracle OCI Cloud makes all of these things available, right? Whether we're talking about serverless technologies, SaaS technologies, analytics, right, or tools required to meet the requirements for governance and security. And right in dead center of the block, you see all of the data management items, right? Things for managing the data, processing the data for your ETL, and of course, we just talked about our 3 core database, cloud database offerings that are there. And along the bottom, we have all of the IaaS infrastructure that you would need to build any type of workload at any scale, right? So the one extra value that the OCI brings to the table over other cloud providers that are just going to give you IaaS is that we have got integrated hardware and software features and functions that run Oracle its best on Oracle Cloud. But it absolutely is a great place to be able to build and integrate whatever cloud-based application that you want. And in the bottom right corner, you see multi-cloud. Again, we've made it very easy to interoperate from on-premise to the cloud and between multiple cloud vendors. So, just a couple quick more things. Oracle tries to make it very easy for you to be able to manage and administer its services. There are a number of management interfaces that are made available for you. They've got the web console UI, which gives you a browser-based access to be able to do great one-time actions and ad hoc tasks. Very simple UI click streams to get it done. There are REST APIs that give you programmatic access via HTTPS. And again, anything that you can do in the UI and in the API, we have the ability to also do that through the command line to extend the console's functionality. This is really convenient for developers, right, that want to automate tasks through scripting. And SDKs, right? Doesn't really matter the SDK type you have. We have a huge library of SDKs that allow us to build and deploy applications that integrate into the cloud infrastructure services. And again, Terraform and Ansible, right? It's all about automation, automation, automation. So we make it very easy for you to actually capture and reuse your cloud state into Terraform scripts that you can use in your automation processes. So, Terraform and Ansible is again, made easily available to you. And so let's take a quick look at the console, right? This is what our cloud console looks like. When we want to fire up the menu, we click the hamburger bar, we click on Oracle databases, and you can see in our menu, you could find the 3 cloud database offerings listed there. So once you click on any one of those, you come to the database details page where you can do any of the administrative tasks that you need, right? Whether it's creating databases, managing databases, creating HA solutions such as DataGuard, backing them up, restoring them, all those great features and functions have been wrapped in cloud automation that's available to a simple click for you. And for today's conversations, you'll notice the same thing. We're going to talk about observability and management, which is just a few lines down from our Oracle database. So we simply would click on observability and management, and we will enter there. So now that I've got you all excited about OCI and you have a good understanding of what is available in OCI, let me turn things over to Derek to discuss more about observability and management services. Derek, I'll go ahead and let you share your screen and take it over.
Sure. Thank you, Eddie. Okay, so as we said, observability starts with the basic cloud services like compute, storage, networking, security, and control plane telemetry. From that, we have built a set of foundational services which help accelerate and protect cloud-native app development. We've developed a service connector hub so services can observe, manage, and integrate with other Oracle services, as well as open standards-based and third-party services. And on top of that foundation, we continue to add advanced services providing capabilities that help customers gain greater insight, solve current business problems, and innovate for the future. These are the services which comprise observability and management. We're mainly focusing on what we have for observability and management platform from a database management point of view. We divide this platform into 3 different cloud-native services. One is database management service, which provides a unified console for on-premises and cloud databases with lifecycle database management capabilities for monitoring, performance management, tuning, and administration in line to what EM offers, with some caveats as this is a growing service within OCI. Now, anything beyond short-term analysis will rely on the operational insight service, providing capacity forecasting based on over 2 years of data. This will help consolidate resources in the enterprise, as well as prevent any unexpected resource bottleneck-related outages. Finally, logging analytics allows you to ingest all sorts of logs, such as alert, attention, network, or any other sort of application log to see a larger view of your environment's health and drill down to specific logs when needing to investigate performance issues or application anomalies. In terms of DB management, it is an on-demand cloud-based subscription service that is natively available in Oracle Cloud Infrastructure as a managed service. It combines the back-end instrumentation and tools that are already available with the Oracle database kernel itself, and you have a rich visualization-driven interface providing a single pane of glass management console for databases that are either deployed in the Oracle Cloud or on-premises. Now, Oracle databases deployed in the cloud could be on OCI Virtual Machine, Bare Metal, Exadata, or autonomous databases. You also have cloud-native capabilities which allow you to have continuous upgrading and patching of the tool itself. You don't have to invest time or resources to manage any agents, data, or the monitoring solution. It allows you to have true cloud elasticity, where you can lower your operational costs. It allows you to connect with Oracle databases 11.204 and above, and the key use cases that you're trying to solve with the service is to monitor and administer databases, obtain performance diagnostics, and manage databases deployed on premises, in the Oracle Cloud, and at other cloud providers. The features comprising the service are designed to minimize efforts in the monitoring and administration of your database fleet. A unified view for managing all of your Oracle databases across on-premise and the cloud provides quicker insights into overall performance and short-term resource trends for your databases. Performance diagnostics are provided with integrated views of database activity. Drilling down into a single resource homepage offer an overview of the performance. The ability to launch Performance Hub allows more detailed performance analysis, which includes Ash analytics, blocking sessions, ADDM reports, and top activity light. Administration tasks like table space management, parameter configurations, SQL Tuning Advisor, Optimizer statistic reports, and more are available in the resource console. So here are the key features within database management. So we allow a fleet overview to see all of your database resources in a single pane of glass view. You can quickly assess database resource utilization as well as performance trends based on historic performance windows. You have the options of looking at the past 60 minutes, 1 day, or 7 days, and comparative analysis to the prior periods associated with them. Metric and event alarms are displayed for your resources, and the ability to drill down into a specific database provides a vital workflow to mitigate any performance or availability issues occurring within the fleet of your databases. PDB support is now available for cloud databases. This includes any database version 19C and above in the cloud, or 12C and above for external database resources. Capabilities previously allowed only on CDBs are now supported for PDB resources, including fleet or single database level features. Cloud PDBs will be included in the fleet summary, and you can create database groups with PDB database resources or filter based on database type. Next, we'll be looking at the Performance Hub. If you're familiar with EM, you likely have seen the Performance Hub before. You can obtain access to real-time monitoring utilizing Ash Analytics, SQL, and session details with information regarding blocking sessions. Historic views can also be adjusted for longer-term performance investigation. You can launch other service features like ADDM on-demand reports, SQL Tuning Advisor tasks against specific queries, or more in-depth SQL investigations with SQL monitoring. Traditionally, Exadata AWR statistics can be difficult to digest quickly. It takes expertise and experience to assess the wait events and I/O statistics. Pending on configuration, multiple AWR reports would be required to get a full picture of Exadata resource usage and can increase time to recovery for system performance. The new Exadata tab in Performance Hub resolves these problems. You no longer need to generate multiple AWR reports and look through the tables to find pertinent outliers. Visualization of the metrics have been provided to quickly assess the overall health of your Exadata system. You can check I/O metrics for read and writes on cells or individual disks. Top consumers can be seen within the details to find any databases that might be monopolizing the Exadata resources. Finally, you can view the configuration of your storage servers as well as ASM disk groups. When generating an AWR report, the wait events are summed up and averaged to show wait events for the entire window. You can see the report showing total waits and average wait time in the report. When looking into performance issues, it can be difficult to narrow down the exact snapshot intervals to investigate to find root cause. Sure, average wait event metrics are useful to show how a wait event was performing between the snapshot intervals, but what if your elevated wait times only happen for a smaller portion over the overall window? You're going to lose granularity of your performance metrics. The overall wait time average is going to be reduced when the system was performing as expected. Here, the control file sequential read wait averages are displayed for two separate snapshot intervals. The first is a single hour within the larger performance window, let's say between snapshot intervals 2 and 3, and the second is a longer period which encompasses the first snapshot interval, snapshots 1 through 4. You can notice the difference in the average wait times, but this only happens if you generate multiple AWR reports and examine each separately. Is there a better way to go about this? Of course. AWR Explorer provides you with a graphical visualization of the most important AWR statistics and will enable you to perform advanced diagnostics of AWR stats. A graphical chart reduces this average wait event problem and allows us to see spikes and patterns by keeping the individual AWR snap granularity exposed over a longer period of time. It is easy to see performance trends and identify patterns by selecting longer time ranges without generating a large number of AWR reports and toggling between them. Short snapshot intervals have always been preferred when trying to identify an issue, but it has also been difficult to maintain because of the amount of data to digest. By presenting several graphs on a page and providing the ability to remove less impactful event graphs, it helps to narrow down the problem and see correlations between wait events. Wait time on a certain metric could be correlated with another metric. Increased amount of login time might be a result of CPU or I/O spikes. If there is a certain pattern or a certain event that may be of interest, then it's possible to drill down by generating AWR reports or Ash reports, or even SQL reports from within the AWR Explorer tool. The AWR Explorer generates top activity from your AWR data, allowing a familiar, convenient tool to begin performance investigations for past time periods. You can quickly find elevated wait events and drill down to additional tabs within the Explorer to gain in-depth data around the database metrics or wait events. The AWR Explorer has a tab for metrics and will show data from the DBA HIST metrics history table. We provide a set of default metrics like average active session, CPU, I/O, network, and logons. And there is a set of graphs not displayed, so if you want more data, select metric and then you can add the chart there. In the same way, it is possible to remove a chart if it is of no interest in your overall load profile. And of course, it inherits the time dimension selected from the previous tab. So you'll have consistent viewing windows for your data and their different aspects. The load profile tab provides system level statistics from the DBA HIST table shown here. And you can also get additional database metrics such as time model overview, connections, or logon information to correlate to any specific wait event spikes during this time. And finally, Wait Event tab depicts top wait events for the selected snapshot intervals. In this tab, we show the top 10 wait events sorted by the wait time for each tile. There are two values. One is the average amount of waits per second, and the other the average wait time. As in all graphs, inherits the time dimension. One thing with the wait events is to understand how long they are. If we're talking about microseconds, then it has a minimal impact on the user experience. But if we're talking about milliseconds and even second-long waits, then it may impact user experiences. We are therefore providing a graphical histogram for each wait event. We divide waits into different buckets, and each bucket is twice as long as the previous bucket. So in this example, most of the waits are around 500 microseconds, but we have two waits that are around 8 milliseconds. This can help determine why some users may complain about the performance while others have no problems. And it can also help diagnose intermittent problems during the intervals to provide a more granular picture of performance between snapshots. Top Activity Lite provides a less resource-intensive view of real-time activity. This allows quicker refreshes of current performance even when the database is impacted by a heavier application workload. You can adjust the data source between database memory or memory and the AWR data. We have a refresh interval that you can toggle between 15, 30, and 60 seconds. And you can drill down on specific sessions or SQL statements to gather additional details for investigation into the performance problems or perform root cause analysis. The time zone selector allows you to analyze data on the database time zone or browser time zone. An auto refresh interval can be toggled as stated previously. A slider is available to gain SQL and session information for the selected time period. From here, you can utilize additional performance tools such as SQL monitoring or the SQL tuning advisor. You can quickly find and sort the largest consumers for the last selected 5 minutes of the interval window. So here's our database management supported deployments. We can see our ADBs, our base DB, Exadata dedicated. We can see the cloud at customer, and we can see the external and on-premise databases. So here's the basic and full management for cloud database offerings. So we do have a basic management that is free of cost. It includes the Performance Hub, Ash Analytics, and the SQL tabs for CDB, and it includes the 14 key metrics for the CDB. PDB level monitoring is not supported with this enablement. That would require the full management, which is an additional cost. And there you get the database fleet, the database summary, and the additional tools such as the Exadata monitoring, RAC, SQL tuning advisor, and other administration features.
Well, Gary, this is a pretty awesome list of things. Maybe this is a really good point if you can move forward just one. And Leo, if you could just quickly just walk us through what it looks like to enable this management functionality on the Exadata service.
Yes, so enabling database management for database cloud service, you can easily do it via the OCI console. And here's an example in which we have a database running on Exadata database service on dedicated infrastructure. In the database details page, you'll see the associated service there, in which you'll see the database management is not enabled. And just click on the enable button, and then it will prompt you to the enable database management details page. So you'll see here a couple of information. So you'll see the type of the database cloud service on which the database is running. You'll see the info for your VM cluster. You'll see the info about your database home, about the database name. And then here you just need to validate the service name that you will be using. And then you need to choose the type of protocol. So you can choose either TCP or TCPS. And then you need to specify the port number, which has a default value of 1521. And then next page, it will just ask you to key in your credentials for the connection, which in this demo, we have created a monitoring user for our database, and then you just need to select the secret password, which is stored on the secret in the vault in OCI. And then you just need to provide the monitoring endpoint that will act as a representation of the database management in the VCN in which the Oracle Cloud database can be accessed. And they just need to choose the management options, whether you want to enable it with full management or basic management, and that's it. So you can click and enable your database management. Easy as that.
Awesome, awesome. Well, you guys are making this a feature that I just can't wait to go and play with some more. And I hope our listeners here will also go out and try this. Derek, maybe you at this point, you can continue on and tell us a little bit more about what's available in some of the other services.
Sure, yeah, absolutely. And thank you for the walkthrough on that. So next we'll be going into our Operations Insight service. So traditionally, performance management has utilized recent data to investigate and triage issues within a database. Workflows generally start with launching Performance Hub to view average active sessions for your database and checking for any spikes in wait events or other anomalies. From there, additional reports such as AWR or ADDM provide a granular data for root cause investigation. And finally, invoking SQL Tuning Advisor for ADDM or ADDM for recommendations for improvements can assist in quickly mitigating issues. Today, performance management is focusing on the proactive solutions to prevent such performance issues. Being able to stop a problem from even occurring is the best case scenario to provide healthy, performant database environments. The Operations Insight service provides many advanced monitoring and reporting capabilities for your entire enterprise. Data is stored 25 months, allowing deeper insights into the performance and trends for your environments. AWR Explorer and ADDM Spotlight provide new ways of consuming and interpreting diagnostic reports for your databases. SQL Warehouse and Explorer stores long-term SQL performance metrics to provide trends across your database environments for specific SQL statements. Capacity planning forecasts critical resources for your database and host resources to prevent unexpected bottlenecks or provide assistance in consolidation of environments. Finally, AWR Hub, EM Warehouse, and Exadata Warehouse are repositories providing a lakehouse for telemetry from various sources accessible for deep operational analytics. Customizable reports or user-driven analytics can be performed on these data sets. ADDM Spotlight provides visualization of ADDM findings and recommendations generated from the AWR snapshots configured for the database. Aggregations of findings and recommendations for each ADDM report are shown on a timeline to provide quick analysis of trends or chronic issues in your environments. Tabs display findings or recommendations tables sorted by impact for the environment to assist in triaging performance improvement tasks. Exadata Insights is a single pane of glass overview for your entire Exadata fleet. Top resource utilization for your Exadata fleet is displayed with trends allowing you to assess infrastructure needs. The trends are generated on historical usage over the previous 25 months. You'll be able to see all Exadata systems with the configuration details, current resource utilization, and at-risk resources. The insights will assist in estimating future needs for your environments. Either consolidation or scaling may need to be considered to maintain your overall performance of your Exadata fleet. As just mentioned, the insights can be utilized in consolidation exercises to reduce costs for Exadata infrastructure. Individual Exadata system details show resource utilization trends. You can drill down to view top consumers by databases or hosts. Tree map views of top consumers within a system quickly depicts the fastest growing resources and trends of their growth based on seasonality. This is where we can utilize the machine learning that Operations Insights provides to depict the seasonality changes over the 2 years of data to get the most accurate forecasting for the resources. And so here's the support matrix for the DB deployments in Operations Insight service. So we can see the categories that we have for the capacity planning, the warehouse, Exadata Insights, and the hub, and then the features that are associated with them. You can see the deployment types and the availability for the features there. So next we will be going through a short demo for all of the features that we've kind of discussed here. Okay, we'll start off with the database management service. And like Eddie had shown previously, going to the hamburger menu under Observability and Management, you will see our services provided here. We can see our database management service and our operations insight service. And if we click on one, we can go into the overview for the service. We get a compartment level view of all of the databases enabled and the total databases located here that have been discovered. And we can start by going down to our fleet summary. So here we can see all of our databases listed out with their resource utilization and their trends associated with them. So we can see the time period we have selected as the last 60 minutes, and we are comparing the same 60 minutes yesterday. We can also change this to be the last week, and similar, we can change this time period to 24 hours or 7 days to have those comparisons. Right now, we are looking at the databases in our fleet, and you can quickly see the average active sessions for each. We can see our CPU, storage, and I/O rates, and then we can see the associated comparison. So looking at 60 minutes yesterday, we've actually utilized slightly less CPU during that time period. We can quickly see the status of our environments and then the overall CPU and storage for the databases running here. And we can see the alarm status for the databases located here to see if we have any critical warning or informative alarms. So then going into a specific database resource, we can go to one of our databases and we'll see the availability timeline shown here, along with some top metrics. And these kind of expose the I/O memory and storage for the database, as well as any additional information. Here at the top, we have our Performance Hub, AWR Explorer, the dashboard links, as well as some AI Ops operations insights links to the capacity planning or our SQL warehouse. So launching Performance Hub will be seen with a slide out menu here where we can see the top sessions. Again, we have the capability of looking at our different average active sessions and changing our dimension if we want to. So we're looking at weight class now, but we can filter this based on session details or SQL details. We'll see this a little bit later, kind of towards the end of the demo, of looking at a specific SQL statement running on a database and how it's performing over time. We can go down and we can see additional information for each individual SQL statements, and we can look at kind of some of the details with the sessions associated with them running right now. As I mentioned before, we have the SQL monitoring page available. Looking at this time period, we can see during the selected 5-minute interval, queries that have been running, their status, the duration, as well as the database times associated with these running queries. So next, we're going to be checking out the AWR Explorer. So going into the container database here, I've actually taken an AWR dump from another environment. And what you can do is you can load it into a database. You can go to AWR Explorer and you can select other DB-IDs associated in the environment. And you can see the database is located here. So I'm going to select this database version, and I'm going to look at these snapshot intervals to look at some historic performance. I'll load the AWR data here into the Explorer. And I'm going to adjust our time period. So instead of having to generate multiple AWR reports, we can change our window that we're looking at reports and quickly generate new views of the AWR data over time for the selected time period. So right now we're looking at approximately 3 days worth of data. We can see the load profile for the environment. And this was the original tab to look at the connections for the databases and kind of the logons, any Exadata associated metrics that might be emitted by the environments, as well as additional wait events here, load profiles. Going over For this specific database, going into the wait events, this will display the top 10 wait events associated with the environment, pulled from the AWR, from the basic top 10 consuming on the AWR report. And immediately we can see that we were having issues with direct path read and writes here. We can see the spikes located in this time period. The average wait time has significantly increased in the environment. By using our mouse, we can quickly expand this time window to get more granular details on it. We can select an individual snapshot interval to look at the performance for the wait, total waits for the wait events. So we can see that with the histograms, we're looking at half-second waits. A majority of them are coming in here, and we have some that are even taking over 2 seconds. So likely during this time period, we were having users experience increased times due to the performance of the database. And scrolling down, we can see other wait events during this time. Even DB file sequential read was impacted, probably causing more slowness for the users during this time period. And so we can go into the histogram for these wait events, and we can see not all of them were impacted, but some of them were taking longer than was probably expected. And finally, another interesting thing is if you can go and see your database parameters during these times. And so right now we have it selected to hide the unchanged parameters. So maybe if we did potentially have an issue during our time period, we could check to see if this was actually due to a database parameter configuration change or if it was due to some other issue. All right, and so now we will be going back to our environments, going back to the Performance Hub. And then if we wanted to look at our real-time activity for our Performance Hub, we can go to our top activity light. Now this might take just a little bit to load up, but once it does load, the new refreshes happen quite quickly just because it takes the metadata in, and then the refreshes only account for the newer information from the reports. So again, we can filter on our ASH dimensions. We can change our data source from memory and AWR or memory. We can change our sample resolution for larger sets, and we can kind of change some of the views as well if we want the bar or the more historical EM area chart view of our environments. And then we do have the SQL monitoring tab within here to look at the selected time range within our selected time period. You can see this would be your top activity light for your database environment. It's a more granular look at your Performance Hub activity, seeing the past 5 minutes detailed here with the individual SQL IDs and sessions associated with them. And then you also have your SQL monitoring tab available as well, which would show up with your SQLs executing during the time. You can sort based on database time to see which ones are consuming the most resources for your environment. And yeah, here it actually did load. And finally, I'm going to go back to our fleet overview. I'm going to go to our fleet summary, and then I'm going to bring up our Exadata tab that we have for one of our database environments. Let me go into the container database here. So here's the Performance Hub. We have the blocking sessions, and we have the Exadata tab exposed here for the environments. Going into the details, instead of having to peruse your AWR data for your Exadata, we have visualized these here. So we can see a basic summary for the resources in the Exadata environments, and we can see the latency associated with your different reads and writes, small, large, and your cells. And then you can see your flash disk and hard disk performance. You see IO requests and throughput for the environment. You can go into the additional Exadata details, and you can find a large amount of metrics associated with the individual Exadata components. So you can see the ADDM, you can see the health. You can go to top consumers, so you can see the top databases within your Exadata system, what are consuming the most IO requests or the QRM time or IORM queue time. And you can see the top databases per cell as well. And hovering over, you can get more information for the individual database. And finally, I wanted to go over and quickly show kind of the disks associated. So you can see the performance of your flash and hard disks, if there's any outliers with latency, if you're having some intermittent performance issues, you can quickly assess the overall health of your disks here. So I'm going to go ahead and go back to the observability management and look at some of the operations insights features that we have previously discussed. So I do need to change my region here, and then I'm going to be looking at departments. So we can see our databases and hosts, and we can look at the capacity planning here within operations insights. So this is going to be the overview for your compartment, and you can see we have an overview of the databases, and then we have CPU, storage, and memory, IO utilization during this time period. And right now we have selected the last 30 days. So we are looking at the trends associated with that time. So we can see our CPU has gone down slightly. Our storage has increased usage 30%. Memory has gone up quite a bit as well. And then we can look at individual resource insights. So we have CPU, storage, and memory here. And the utilization is shown that 5 of our DBs have had high, greater than 75% utilization, and 15 have had less than 25% utilization. So looking at the 30-day forecast of these trends, we can see that 8 additional databases are going up into the 75% range, and we're going to stay consistent with our low consumers. So this is a quick way to assess how your databases are growing and if there are any at risk for resource utilization bottlenecks. And then finally, you can see your top consumers here based on the resource, as well as the usage trend. Drilling down into a specific resource, we can find our trend lines and forecasts for an individual database. So right here, we can see trend and forecast setting down here. We are looking at, again, the past 30 days, and then we are forecasting 50% of that, so 15 days on top of that. We can change our linear regression or seasonality for the machine learning timelines. So we'll look at additional events rather than just the linear regression for forecasting the data. We can select our max usage and our max forecast because obviously when we do hit these spikes, we are going to be having performance issues. And so we can also trend on these max usages. Similar, we have capabilities for forecasting within our Exadata fleet. Let me change my compartment down to our Exadatas. And so within this compartment, we have our Exadata resources. We have 5 different Exadata machines here, and we're seeing a consolidation use of the resources here so we can get an overview for all of our machines and how they're performing and how they are growing in the environments. And then here, we can change the inventory by rack size, so we can see what we have here. We have a few quarters, a few half, or a single half, and a few full racks. Below, we can see the current utilization and forecast for each individual system. We can see them listed out here. Some of the configurations. We can see the utilization of their highest metric resource, and then we can see how long until we are reaching that time. So right now we can see we have an 80% usage. I think our utilization is probably set at 75. And so right now we are reaching that. For this environment, we have a roughly 16 days of time until we hit that 75% usage. We can drill down into the environment to gain additional details for this Exadata rack. We can see our software and hardware inventory. We can see the configuration of it. And then we can view all of our key metrics for the environment. So not just the top consumer, we can see the memory, IO, and Exadata storage and their time to utilization as well. We can look at the top consumers for the database or for the Exadata environment. So we're looking at all of our databases located here in a tree map, quickly assessing their usage as well as their utilization. And so we can change this to look at their usage change percentage. So we can quickly identify any database that is either growing excessively or has really dropped in their usage. And below, we can see a consolidation trend and forecast for the databases on this system. So right now, we don't have a whole lot of activity in CPU. It's fairly low. So we could look at either consolidating or reducing our CPU resources here. But if we would go to, let's say, memory and take a look at it, we can see that our memory has gone up within the time period, and we are forecasting a trend to continue to increase over time. And we can look at our usage change for these environments. They've all gone up by 50% to 100% change in their memory usage. And finally, we can look at our Exadata storage server details. So we can see how the storage is performing, the IOPS and then the throughputs, as well as the capacity for either our disk groups or our individual storage servers based on what we were looking at here. So we can see total storage usage and then our throughput. All right. Next, we are going to be taking a quick look at our ADDM Spotlight. So here we can see an overview of all of our databases, the findings associated within our ADDM reports, and then we can see the max overall impact of our ADDM findings. So we can drill down into the individual database. We get a summary of our findings on this tab. So we can see over the last 30 days, it looks like we've only had this activated for roughly a week, but we can find our top findings within ADDM. Look at the frequency. So over the 167 snaps, this finding has occurred in all of them. And we can look at the max overall impact of those changes. So we can kind of triage which is our most impactful changes to improve performance for environments. Likewise, we can look at the recommendations associated with our findings. And so it looks like this is a PL SQL statement, so we can't do too much tuning through ADDM recommendations, but we could still look at how this is performing and improve the performance there for the SQL statement. And finally, we can get an insights into our database parameters. We can look at non-default values for the time periods. We can look at high impact parameters. We can look at parameters that have changed over this time periods. And then again, recommendations that ADDM has given for the parameter configurations. And so I know we haven't really gone over application performance monitoring, but we do have some capabilities of drilling down based on SQL that I wanted to show. So if we go into our Trace Explorer here, let me go ahead and change my compartments. We can look at our traces for our environments, but we also have the capability of looking at SQL performance for an individual database environment. So here we can bring up all of our SQL statements. We can look at some of the top average span for the time for the SQL to run. And we can see that 561 of these statements have run during this time period. And then we can see kind of the span duration, and we can sort this to find our longest running queries during this time. So we can look at the span duration. This one looks like it took 38 seconds to run, the start time of the query. We can drill down to get additional information here as well. So we can look at the span ID, the duration that it took, the trace ID, and then we can see additional information on which application server it came from, the database connection URL that it is using, the statement, the SQL statement that it is using, the SQL ID associated with it. And we can configure additional drill down menus. So we can launch Perf Hub from here to check out how this SQL is performing on this database only. So if we look at the applied filters we have, it is that SQL ID coming from our application performance monitoring, and we can see the associated weights and times for the SQL statement specifically, and what sessions have been running it and how they've been consuming the average active sessions for it. And likewise, you can drill down into the actual database environment here too, to get more information from where that is running. I know we have a couple of minutes left. I wanted to finally quickly touch on some of the configurations for some of our alarms. So if we want to set some alarms on, say, capacity for our environments, let me go ahead and change this to database management. We can go to create an alarm, and we can give it an alarm name, a severity, and then using our namespaces with an OCI, we could choose one such from Operations Insights. This is where we are going to have some of our individual resources like days to reach high utilization, or some of the SQLs that might need attention for performance. So we could create days to reach high utilization. We can provide it a resource type. So if we wanted to give it a specific database that we have running here, we can say the trigger rule, if it's greater than 75% utilization, go ahead and run, or actually this would be 15 days to reach utilization. Go ahead and send an alarm for capacity for the environment. Then we could configure a notification to be sent out. I have some set here, or we can create our own notification. So you can designate the topic name, and then we can send it to like an email function, HTTPS, pager, Slack, or SMS. So we can provide that here to quickly set up a notification for users. I know that was quite a bit of a demo, but I believe that was all I had for the demo there.
Derek, that was an amazing job. I really appreciate you taking the time to walk us through this. You know, I got like super excited around the Operations Insight capacity planning. You know, I can absolutely see our customers using that to get a handle on exactly when their resources are need replenishing and getting their arms around exactly what is using their resources. So thanks for sharing. Thanks for the great easy viewpoints on how we can use the drill down features. So hopefully our users will go out and use all of these things. Leo, you know, if you will just take us home and kind of help our users understand, you know, how they can stay in touch with us and learn a little bit more.
Okay, let me just share my slide. So for the resources, so we have a community. So we have a public external Slack workspace. So it's called Exadata Database Service. So we are sharing those publicly available technical assets that we have, starting from get started guides, how-to demos, and GIFs. We're also sharing there the replay of this Tech Talk, as well as the additional references for observability and management links. And for you to join our community, so join our discussion. So it's anything about database cloud services. So here's the join link to our public Slack workspace. So all you need to do is to click on the join link, log in your email account associated with Slack, set up your 2FA, and that's it. So welcome to our workspace. And in the same workspace, so you'll see the different channels there. So we have a dedicated channel for all the technical discussions and questions. We also have a dedicated channel for Tech Talk. So if you have follow-up questions about this session, you can post in your question there. And we also have 2 intelligent chatbots available as Slack apps. So if you have inquiries, anything about OCI CLI and DBAS CLI, just hit the Add Apps, search for Ask Debbie and Ask Ed. So those are our two digital assistants that can help you on your inquiries on OCI CLI and DBAS CLI for database cloud services.
Hey, Leo, I want to jump in. One last quick reminder. Starting June 1st, certifications for our courses are going to be free for the summer. So go out there and visit Oracle University and take advantage of the free course, and also take advantage of getting certified for free during June, July, and the summer months there. So again, my name is Eddie Ambler, and my co-host is
Leo Alvarado.
And we've been absolutely graced with the great presence of Derek Harlow, and I appreciate you all for taking your time to spend with us. Until next time, thank you.
Bye.